Hello everyone, this is Professor Damien coming with another video. Today's topic is going to be about factoring polynomials. So, right here is the symbolic definition of a polynomial. Or, sorry, not a polynomial. It's a trinomial, binomial, it's something. I think it's a trinomial. I'm sorry, it's pretty late. I'm just recording this video because one of my friends is needing help with this, and I thought it'd be a kind of interesting topic. So that's basically it. And so you'll notice they have three different values or three different. Okay, let me rephrase that action. So right here, A and B are what are known as coefficients. So coefficients just basically mean that they are right next to an x value or just simply any variable at all. And then we have a constant right over here, just means that it's not right next to a variable. And so uh, when you are factoring, now let me get down to what factoring really is actually. So I'm going to write down a little example right over here. So let's say we have r, I'm sorry, I know it's a pretty slow, but yeah, r squared plus 6r minus 27. Okay, so what even is factoring, really? Factoring is just basically we're going to be making this whole polynomial smaller, um, well, not smaller, but more easy to digest because, like, what really is this? You know what I mean? Like, you see that it looks kind of confusing, especially if you're not familiar with stuff like this. So, how we're going to do this is using something called the X method. So you see I have right over here. Now the top value that you're going to put on your X or on top of your X, yeah, is going to be A times C. So the A corresponds to this A that's up here, the C corresponds to this C that's up here. So you're just basically going to be multiplying A times C. And then you also got to make sure that it adds to B as well. So, like I'm saying this, but maybe it sounds a bit confusing. So, whenever you have something like this, right, just simply r squared, and there's no, well, there quote unquote isn't any coefficient right next to it, it actually is just simply an imaginary one. Well, not an imaginary one, sorry. It's just one, but we usually don't write it because it's kind of intuitive, but for some newer people who are newer to the subject, they may not completely know that. And that's perfectly fine because it was in fact something that I was confused on when I first started learning this. So, but anyways, we're going to draw a little x over here. Bum, 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 bum. Bum, bum, bum. Okay, so we have our x set up. So now it's going to be 1, since that's our a, times, whoa, the c, this is also our c as well. So it's going to be 1 times negative 27. And now our b value, it must add up to b, right? So our b value is the one that's in the middle, and it's right next to the x. So it's going to be that value right there. So right here, you'll see this is our b value actually, 6. Oops, sorry. So we have 6 right down here. Bum, bum, bum. Isn't that interesting? Now, what do these two little things on the side mean? So F1 and F2 stands for factors. So factor 1 and factor 2. And you can see that they're both being divided by A. Bum, 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 bum. You can see that. So basically, we want to be able to find a number or two numbers that multiply into negative 27 and also add up to 6. Now, what two numbers multiply into 20, or what numbers multiply into negative 27? Let's think about it. So we have negative 3 times 9 is equal to negative 27. But we can also use negative 9 times 3 equal to negative 27 as well. Interesting. So we have two different we have two different things that we can choose from. We could either choose from option 1 or option 2. Now, so we see that they both multiply, these two equations both multiply into negative 27, correct? But we also need to make sure that they add up to 6. So using this, we will be like, okay, what is negative 9 plus 3? That is negative 6. Well, that doesn't seem like the right one because this is positive 6. We don't want a negative 6, right? So we can simply just use 9 minus 3 is equal to positive 6, which is right on the value of 6. Whoa, isn't that kind of cool? So now we have 9 divided by our a value. Remember, our a value, which is just 1, negative 3 over 1 as well, because remember we're dividing both sides by our a value. So we've broken it down, and now how you would write this in equation as an equation is r plus 9 times r minus 3. And maybe I'll do this in a separate video. Right now it's pretty late and I just want to get through this stuff, so it's kind of just over a review of everything, of like polynomials and stuff like that. Really, it's not like I'm not going to go into depth of it, but basically if you were multiply these two right here, you would go back and go back up here. So basically the all of this right here is just a simplification of this. But this one leads up to that one, and this one leads down to this. I hope that makes sense. Now we're gonna go into another example that doesn't really you can't really use the X method, and sometimes, hold up, give me 1 second, please. Alright, sorry about cutting the video. I was having computer troubles for a quick second, but now everything works. So now we're going to be factoring this polynomial, x squared minus 4x. What the heck? Like, you just taught me about the X method, but this doesn't look like we can use the X method because there's only two values. Like, what is this? So when it comes to something like this, where it is a variable minus, plus, multiplied, whatever, by the same variable, it doesn't matter what this is, right? It doesn't matter at all. It could be 1 billion, jillion. It doesn't matter. You could still do the same thing that I'm going to show you right now. So with this, we can take out an x on both sides. So imagine we are dividing by x, right? So we're just basically taking out an x. You'll see that this x gets canceled out, and then the x squared gets canceled out, and the bottom x gets canceled out. So how would you write this? It'd be x times x minus 4. You notice if we do the math and we distribute the x right here, you go back to where you were at the beginning, x squared minus 4x. I hope that was pretty easy to understand. And now we're going to go on to our final example. Now this one is one of the more trickier ones, and it's a little bit more confusing if you are new to factoring. but I'm going to try and explain it as best as I can. And if you need extra help or extra guidance, please let me know down in the comments. So it's going to be 24. Ha, terrible, 24. Okay, 24 p cubed plus 16 p squared minus 9 p minus 6. Okay, I know this may seem a lot right now, but we're going to break it down into smaller chunks. So notice something about this, right? We have negative 9p minus 6, right? And you notice that they have a common these two numbers right here have a greatest common factor, which is just GCF of 3. Dun, dun, dun. And then you'll notice that these two numbers right here have a GCF of 8. I wonder if we can use this for anything. So what I'm going to do actually is I'm going to break them up into parentheses, or group them up, I should say. So let's imagine we have a parentheses right here, or not imagine, I'm literally writing it down, so I don't know what I'm saying. 24p cubed plus 16p squared parentheses plus negative 9 p minus 6. Now this is where we can actually take out the 3 from this side and the 8 from this side, and it's just the same trick that we did last time, but instead of a variable, or in the same trick that we did in the previous question, but instead of taking out a variable, we are actually taking out numbers. So we're going to divide this whole entire side by 8, divide this whole entire side by negative 3, because we want to turn these numbers into positives, and you'll see why in a moment. So we're going to take out 8 from this side, so it's going to be 8 times parentheses 3p. Oh, actually I did a mistake too on the side. Sorry about that. So right here you'll see that we also have p cubed and p. That's terrible, but you can see them, p cubed and p squared. So we could take out a p squared on this side too. So in fact we can take out 8p squared, which times the 8p squared parentheses 3p plus 2 minus 3, because remember we're dividing this whole section by 3. So it'd be 3p plus 2. Wait a minute. Doesn't that seem kind of familiar? We can use the distributive property again. 3p, because these are both the same values. Boom, boom. So the final way that we would write this is as parentheses 8p squared minus 3 times parentheses 3p plus 2. Whoa. And so doing this, we have simplified this down into a much more manageable and easier form to understand. Whoa, isn't that cool? So That's basically it for today's video. I hope it helped you guys, and I hope it made sense and everything. Any questions, any concerns, any comments, please leave them down below. I'll respond to them. If there's any other practices that you guys are having trouble on, please just let me know. But thank you for your time. I very appreciate it. Bye.